Okay, here we've got some data about scores on an S3 test before and after a revision course, and the claim is that the average score is higher after you've done this one-day revision course. That's what you'd hope. So is that supported by the data? Well, now we've got, this is a matched pairs design. We've got, for each person, we've got 2 scores. So we can look for each person how the score changed. So we're actually going to be interested in the difference in 2 scores. And step 1, which is hypotheses, we express for these matched pairs tests, we express our hypotheses in terms of the difference in in terms of the differences, but specifically because it's a sign test, okay, we're going to be interested in the median difference. Okay, so our hypotheses are about median differences. In the case of H0, that is always that nothing interesting is going on. In other words, that the median difference in scores is 0. Now, in the case of H1, the claim that's being made is that the course improves scores. So I'm not interested in any evidence that people get lower scores afterwards. So I'm only interested in differences being positive rather than 0. So the alternative hypothesis is that the median is greater than 0. And because it's only greater than that I'm interested in, this is a one-tailed test. So I've got my hypotheses. Okay. On to work out the test statistic. Okay, well that's based on the number of differences that were positive and those that were negative. So if it's gone up, that's a positive difference. So the difference here is positive. Here it's gone down, so it's negative. This is a positive difference. Up, up, down, up, 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 down, 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 up, up, down. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 differences that went up out of a total of 15. Are there 15? Are there 6 of the others? 1, 2, 3, 4, 5, 6. Good. So it's 9 out of 16 went up. So I need to work out my test statistic based on that. So step 2, the test statistic. Okay. Well, I'm going to be using X is the number of positive differences. So, if the probability really is a half, okay, I'll have a binomial with a probability of 0.5, and there were 15 people. So, according to this binomial distribution, we worked out that 9 out of 15 had scores that went up, so I need the probability that X is 9 or more out of 15. So 0 up to 15, near 9 we've got 8, we've got 10. Okay, so I'm interested in 9 and above, alright, but my calculator will only look up the probability of 8 and below, so I need to do 1 minus the probability that X is less than or equal to 8. So on my calculator in normal CD, I'm interested in an X value of 8, and this one had an N of 15, and the probability is 0.5, giving me a probability of 0.696. So 1 minus 0.69638 it was, okay, which is 0.30362. Okay, so that's my, if you like, my test statistic. My critical value is the significance level of the test, and it said at the start of the question that I'm doing the 5% significance level, so my probability is going to be 0.05. Now we always have to think for the sign test, do I want just this tail or do I want 2 tails? So I've just looked at the tail of high values. Well, this was a one-tailed test. I'm only interested in whether there's evidence that the scores have actually got better. The median's greater than 0. So therefore, I don't double this. So my comparison is between this 0.0362 and the 0.05. So has this beaten the significance level? Well, no. This is quite a big probability. I need it to be in this small tail in order to be significant. So this is greater. This is not significant yet again. Okay, so because it's not significant, we're going to be, once again, we're going to be accepting H0. And because I'm accepting H0, my conclusion in context is that going to be that there is no evidence that the median score is improved. Oh, and I should state, yes, definitely I should say at 5% here, and I should say at the 5% level here. So I've interpreted in context. Okay. All right, but we're not done on the question, because there are a few follow-up questions. Why was the order of the papers randomized? So we need to go back, if we didn't read this properly before. 2 different previously unseen S3 papers were taken before and after the students went on the course, and the order of taking them, it says, was randomized. Why did they do that? Well, if one of the papers had been easier than the other, that would have made the experiment unfair. So one paper may be easier. Now, you'd want to try and avoid that, because it could be, and the reason why we haven't got a significant result could simply be because some people were taking the harder paper second, and it wouldn't have been obvious that they'd got better at statistics, which they may have done. Okay, so that's why you should design things to be as equal as possible, but as long as you randomize the order of your papers, you're not at least introducing bias one way or the other. So it's still a fair test, because it happened one way round as often as it happened the other way round. Okay, next question. If the test had shown evidence of improvement, why might it still be invalid to conclude that the revision caused the improvement in scores? So you're probably expecting this to be something about whether the sampling was random. But in fact, in this particular case, all right, we are told that this is a random sample of 15 students. So that's not the answer in this particular case. We've got to think a little bit more deeply this time. Okay, why might it not be concluded that it was the revision course that had caused the improvement? Well, the experimental design means that they have to do a paper and then go on the course and then do another paper. So there's a time lapse involved here. They could have done other things in that time, but one thing we know they've all done is that they've done at least one paper as practice before they did the second paper. So even if you did one S3 paper and then immediately did another S3 paper, it may be that you're better second time round because you've just done one. So we can say that the performance could be improved just by the students taking the first test. And there could be other things going on. They could have actually done work on their own in between the 2 papers as well, for all we know. So you can say things like that. But I think this is the most obvious point. And part D asks us to criticize this test. I mean, if we actually look at the differences themselves, it suggests we look at the size of the differences. So did they get the scores go up a lot or down a lot or just a bit? Well, the ones that went up, this has gone up by 12 marks, this has gone up by 35 marks. So quite a lot of the ones that go up are going up by a significant, I mean, this is only a small increase, but a lot of the increases are by large numbers of marks. Whereas the ones that go down, this is by 1 mark, this is by 2 marks, this is just by 4 marks. A lot of the scores that went down didn't go very far down. So it could be that we're missing something here. The sign test, just by looking at which direction it moved, doesn't actually pick up how far they moved. And that's inevitable for the sign test, because the sign test is not allowed to assume anything about the distribution, and the distribution may not be symmetrical. So that's a problem with the sign test. It's just not very good at picking up extra clues that might be offered by the fact that some of the differences are bigger than others. So our answer to this would be, so the increases were much bigger than the decreases on average, but the sign test doesn't take this into account. It can't, because it's a completely distribution-free test, and in order to take this into account, we do need to make some assumptions about the distribution. And the next test, test 4 in this booklet, the Wilcoxon signed rank test, is still a distribution test, free test, but it makes one assumption about the distribution that does allow it to take this kind of thing a little bit more into account. Okay, and part D, explain the meaning of a type 1 error. Well, it's an error, so we must be doing something wrong. Okay, if it's a type 1 error, then we are wrongly rejecting H0. Okay, and H0 was the median difference being 0, so we'd be rejecting that and concluding that the median difference is greater than 0. So a type 1 error would be to conclude that the revision course is having an effect when really it isn't. So, i.e. conclude that the median improvement is greater than 0 when really it is 0. Okay? Or we could say to wrongly believe that the organisers claim that the course improves people's scores when really it doesn't have any such effect.